This video is going to review exponent rules. The first thing that I want to review is to make sure we understand how to read this. So when we have a number next to a variable, that means multiply. So this is saying 4 times x squared. And now let's review what an exponent does. An exponent's job is to tell you how many times to multiply the base. So this is saying 4 times x times x. So that's what this would look like if I expanded it out. Oftentimes, so this is wrong, oftentimes students think that this is saying 4 squared, which is 16x squared. So that is absolutely wrong. If we wanted the 2 to be distributed to the 4, we would write it like this. So this would represent that it's 4 squared and x squared, that it would go to both of them. Okay. All right. So if we take a look at our first example here, we have 3x squared times 4x cubed. So these are rules for exponents. So this 3 and this 4, those are not exponents, so we're going to multiply them just like normal. 3 times 4 is 12. And then the rule is to add the exponents. So 2 plus 3 is 5. So we get 12x to the 5th. So our rule is to add the exponents when we multiply. Now, again, remember, if you forget that you can always expand the problem and write it out, and it will tell you what to do. So for example, this is saying 3 times x times 4, and then 3x is being multiplied. So if ever you forgot that you were supposed to add the exponents, if you write it out, you could see there's 2 here and 3 here. That makes 5, and 3 times 4 is 12. All right, our next rule is when dividing. So we know we're dividing when we see that fraction bar, and the rule is to subtract the exponents. So the 5 and the 10 here are not exponents. So we are going to simplify 5/10 just like normal. So 5 can divide into both of these, and we would get 1/2. So that part is just like normal. Now our rules apply to the exponents. So we are going to subtract, and it's always the top exponent minus the bottom exponent. So numerator minus denominator. So 4 minus 3 is 1. And when we get a positive answer when we subtract, that tells you how many are in the numerator on the top. So then here we have, for the y's, 5 minus 2, that's 3. So that's why I'm putting it in the numerator. We could also write this as xy cubed all over 2, because when you multiply anything by 1, you get itself. Okay, next let's talk about when we are adding and subtracting. So when we look at this problem, it says 3x squared plus 5x minus 9 minus 8x squared plus 2x. Whereas this problem here said multiply, so we added the exponents. Here, when we are combining like terms, we're going to keep the exponents the same. So we can only combine them if they are like terms. So they have to be like terms. Whereas when you multiply, do you see how these are not like terms? X squared and x cubed. But when you are adding and subtracting, they have to match. So I can put a 3x squared with a negative 8x squared. And remember, the exponents are staying the same. The only thing that you're doing is you are taking the coefficient and doing 3 minus 8. So 3 minus 8 is negative 5. And then we have positive 5x and positive 2x. So those are like terms. They both have matching variable parts. So I have a positive 5 plus 2, that would make 7x. And then we have this negative 9 all by itself, and that would be our final answer. So again, the reason why we are not adding the exponents is if I write this out, This says 3 times x plus 5 times x. So if I just stop right there, that is why we can't add the exponents, because there's this plus in the way here. Remember, if I were to count the x's and put 3, an exponent means that there are 3 x's multiplied, but these are added. So that's why you can't add the exponents when you are adding and subtracting. Exponents are for repeated multiplication. All right, let's go ahead and take a look at the next one. Now, what do we do if there's an exponent on the outside? So what we're going to do is you're going to distribute the exponent to everything inside the parentheses. And the rule is you're going to multiply the exponents. So this -3 here is not an exponent, so I'm going to do it just like normal. -3 raised to the second power. So if you look at the difference here, this is all in parentheses, so that's why the exponent is distributed. If we go back to that first problem we started with here, do you see the difference? This 2 just goes with the x because there's no parentheses. Whereas this problem here, there are parentheses, so we distribute. So this is going to be -3 squared, so that's -3 times -3, which is +9. And remember, if you have a calculator, you have to put parentheses, -3 squared. If you don't put parentheses, it's going to be wrong. And then you're going to multiply the exponents, so 4 times 2 is 8. And then 3 times 2 is 6. Now again, if ever you get stuck and you're not sure what to do, you can easily just write this out. This is saying -3x to the 4th y cubed, and it's saying there's 2 of these. So -3 times -3 is the 9 here, and then you'd have 4 here and 4 here, that's 8, 3 here and 3 here, that's 6. All right, next one is, what do you do if you have a 0 exponent? Well, anything to the 0 power always equals 1. So 5 to the 0 power, that equals 1. I mean, your calculator will also tell you that. 5 raised to the 0 power is 1. So that means x raised to the 0 power is also 1. Now this one you have to be careful. This is saying 3 times x to the 0. So the 0 exponent is only with the x. So therefore this part right here is 1. And then you'd have 3 times 1, which is 3. So the answer to this one is 3, but it still utilizes the 0 exponent rule. So also remember what a 0 exponent means. It would represent a situation like this. Whoops, let's do this instead. A 0 exponent means that they're gone. 2 minus 2 is 0. There are no 5s left because the denominator and the numerator divide out and make 1. Because 25 over 25 is 1. So this is a proof. This is what a 0 exponent means. It means there's none left because these all divided into the numerator. All right, lastly, the last rule we need to review is, what do negative exponents do? So I say, in my own words, they move location. So for example, if I had 3 to the -2nd power, I'm still doing 3 times 3, which is 9, but that answer is going to move to the denominator. So whenever you have a negative exponent, it's going to get rid of the negative and move it to the denominator if it's in the numerator. So we would get 1/9. Now your calculator also does negative exponents. So if I do 3 raised to the -2nd power, it's going to give it to you as a decimal, and then if I convert it to a fraction, It's 1/9. So the calculator also computes with negative exponents. Okay, now if we look at this one again, you got to be very careful. This -2 is just for the x. So it's saying 4 times x to the -2nd. So if something has a negative exponent, it's going to move it to the denominator. Okay, so if we look at this one, the negative is already in the denominator. So to get rid of that negative, we have to bring this up. So that's why I call it moves location. So the x to -2 is going to come up. But the 3 and the 4 are going to stay because they don't have negative exponents. So just whatever has a negative exponent moves location. So this had a negative, it moved down. This had a negative, it moved up. It switches its location. Now with this last example here, we have a division problem. And we know that when we divide, that we subtract the exponents. So it's always the top exponent, so 5 minus 3, which is 2. When you subtract and you get positive, that means the x squareds are left in the numerator. Now we're going to do 2 minus 6, and that equals -4. So that means they're going to be left in the denominator. But there are none of these problems have negative exponents because we now know what to do. So now let's talk about why, because this was negative, it moved to the denominator. So if we write this out and we draw a picture, this says 1, 2, 3, 4, 5. So 5x is being multiplied and 2 y's all over 3 x's and 6 y's. This would take forever if we had to write out every problem. That is why we learn these rules here. So when you have the same thing in the numerator and the denominator, it gets crossed out because it makes 1. This makes 1, this makes 1, this makes 1, this makes 1, and this makes 1. So what you're left with is x times x, which is x squared, and then 1, 2, 3, 4 y's in the denominator. So instead of having to draw this out to get this answer here, that's where we use our exponent rules. And if when you add the exponents or subtract the exponents or multiply them, you get a negative, that means you're going to move it to the denominator. If the negative is already in the denominator, you're going to bring it up. Okay, so next there are 12 problems that for practice. Some of them are a little bit harder than others, and they utilize these rules that we just went over. So go ahead and try those 12 problems, and then click on the video next to each problem to see the video solution.